Well, we're getting a little bit more modern for today's test. This is the latest Minelab Vanquish 460. Never used one of these before. This is the first time I'm going to give it a run out. Switch it on. Go through to noise cancel. We're going to be using it in field as opposed to park and beach. Mainly because it's better in field. Most detectors are anyway. Right, I'm going to the menu. That's the volume there we got on maximum. That's the notch. That's the iron bias that I've put on 0. Well, it defaults to 0 on field. The backlight, headlights, should you be detecting in the dark. Vibration, and wireless headphones. Back to the start screen. And we're going to be using it in all metal mode. This one's fitted with the 10-inch coil, the V10X, which I think is about a nice average size, to be perfectly honest. No doubt you get a little bit more out of a 12-inch coil, but it's also a bit more cumbersome, should we say. So, on with the test. I will start with a gold chain, 20 inches long, rolled into a ball 1 inch below the surface. Your typical Minelab 1 for gold, 5-inch long gold chain, same again. Small Roman bronze. Happy with that. Pewter button 4 inches. Pewter button 6 inches. Same again, 7 inches. 8 inches. Coke. No doubt that will be a number 1 as well. Yep. And so will the Galena. They all Minelabs do exactly the same. Thin copper ring, 8 inches deep, a small one. Copper ring, 10 inches deep, slightly bigger. On to separation and discrimination. Iron cord 2p. Bit of a mixed signal on that one. Crown bottle top. 2 coins, iron low conductivity, 8 inches deep, 1 inch apart. It actually seems as if it's getting both of those. Same again, only 3 inches deep. Definitely is on that one. Ring pull 20p. That's the ring pull. 20p. Exactly the same. Low and high conductive coins, 3 inches deep, with a steel staple sitting in the middle of them. Onto the low conductive coins. Start with a 5p at 6 inches. 7 inches. 8 inches. 9 inches. 10 inches. Just 11 inches. Nope. Cut quarters. 2 inches. 4 inches. 5 inches. 6 inches. I'd probably dig that. 7 inches. Gets that one better. And onto the 5 pences on edge. 4 inches. Both ways. 5 inches. 6 inches. 7 inches. Not quite there. High conductive coins. We'll start with a Georgian halfpenny. We can probably go up to 9 inches on this. Just about. 10. 11. 12. Not bad, that isn't. Georgian halfpennies on edge. 6 inches. Both ways, no problem. 7 inches. 8 inches. 'Not quite there, down the length. Alright, cartwheel pennies. We'll start with a 10-inch one. 11 inches. 12 inches. Cartwheel pennies on edge. 8 inches. 9 inches. 'Nope. Right, onto the artifacts. Musket ball, 7 inches. Small bottle, 6 inches. 8 inches. This is a weird one, Mister, because there's no iron down that hole whatsoever. I've been down that hole twice now. As soon as you pull the bottle out, the iron tone goes. So I'm just detecting now, just in front of it, and he's getting it. Some of these signals are really weird when you get going on them. There's no logic to it. Why you get the signals you get. Fibula, 3 inches. 5 inches. Also on this bottle, 15 inches. Large musket ball, 10 inches. Just about, I think. Fibula, 7 inches. Large lead weight, 14 inches. Thimble, 12 inches. Teaspoon, 13 inches. Small bottle, 10 inches. Do you know how to measure? Right, onto the silver coins. We've got a Victorian silver threepenny bit at 6 inches. Victorian sixpence at 7 inches. Shilling, 8 inches. Ahmed Edward penny, 6 inches. Ahmed threepenny bit, Tudor, 8 inches. silver threepenny bit 8 inches. Sixpence 9 inches. Shilling 10 inches. Just nearly getting that. Florin 12 inches. Not quite. And finally onto the iron and boards. It's a horseshoe 6 inches. Iron bottle 6 inches. 20 pence 8 inches deep with 3 nails sitting on top of it. Same again, only the nails are now 4 inches above it. This is an 8 inch deep 20 pence with 3 nails now on the surface directly above it. So it's completely matched that out. Some detectors will then actually get it from the side. Unfortunately this one isn't one of them. Knife blade with 2 copper rivets sticking out of it. 22 inches deep. Just one spot where detectors, if able to, have the ability to, will get it matched there, but it isn't quite coming up with the goods, that one isn't. Large iron nail, 6 inches deep, with 20 pence sitting directly on top of it. This is coke 1 inch deep with an halfpenny 6 inches deep below it. There's your coke coming in at number 1 and then normally you would get your halfpenny just in front of it there, but this is not happening. I don't know why that isn't doing that, because everything else does it. Penknife. Horseshoe 2 inches, 20 pence, 6 inches below it. Again, some detectors will get it from the side. Yeah, just about. 20 pence, 2 inches, horseshoe 6 inches below it. 6 halfpennies stacked on top of each other, 11 inches deep. Does get it, but not as well as I thought it was going to get it. The sensitivity on maximum. So that makes a big difference. 100 mixed coins in a pot, 20 inches deep. And finally 6 halfpennies in a row on edge, 2 inches deep. It's easy to design from that way and non-close the other way. Out of interest, I'll just show you what happens when I put the iron biased on 2 as opposed to 0. This is the horseshoe. Now virtually rejecting it, and also the iron bottle at 6 inches. Totally rejecting that. That's a very, very good detector from Minelab, the latest Vanquish. But somehow when you've used it, you think, I've used this before. I mean, how long can we keep reinventing the same detector? I mean, all the manufacturers do it. Just churn out the same thing in a different package and with too little a few little tweaks. To be perfectly honest, most new detectors that come out nowadays are very good. So it's whatever you fancy, really, I suppose. Oh, thanks for watching anyway, and I shall be back very shortly with another video. Bye for now.